In this video, we're talking about linear approximation for multivariable functions, and in this particular problem, we've been asked to use linear approximation to find the equation of the tangent plane to the function f of xy is equal to 3x squared plus 5y squared at the point 1, 2. And as a reminder, we always use this formula when we're doing linear approximation. All we're really doing here is finding the equation of the tangent plane at this point. This linear approximation instruction, don't let it confuse you. You're just finding the equation of the tangent plane. And really all that's involved there is finding specific values to plug into this formula, plugging them into the formula, and then simplifying to get your final answer. So what values do we have to plug into the formula? Well, first of all, you can see here that we have the point x1, y1, and z1. Well, we've already been given x sub 1. It's 1 right here, so 1 is going to go in for x sub 1. We've also been given y sub 1. That's 2, the y value in the coordinate point, so that's going to go in for y sub 1. Now we're going to need z sub 1. Well, the way that we're going to find that, keep in mind that this function, f of xy, the function f in terms of the two variables x and y, we can rewrite that as z is equal to 3x squared plus 5y squared. You can always replace f of xy with z. So to find z sub 1, all we do is plug in the point 1, 2, and we get z is equal to 3 times 1 squared plus 5 times 2 squared, or z is equal to 1 squared is 1 times 3 is 3, 2 squared is 4 times 5 is 20, so plus 20, z is equal to 23. So this value here then, 23, that is going to go in for z sub 1 right here, and really what we can say is that we're finding the equation of the tangent plane to this function at the point 1, 2, 23. That's really what we're saying there. So we have those three values. That's how you find z sub 1 if you don't already have it. We're going to be plugging those in. We're going to leave x, y, and z as part of the equation of the tangent plane, which means the only other two values we have to find are the value of a and the value of b. And a is just the slope of the tangent plane in the x direction. We know that because a is multiplied by this x value here. So a is the slope in the x direction. B is the slope in the y direction because b is multiplied by this y value here. So how do we find a and b? Well, a is just the partial derivative of the function with respect to x evaluated at the point we've been given. B is just the partial derivative of f with respect to y evaluated at the point we've been given, which means we have to find first order partial derivatives of the function. So we'll say that the partial derivative of f with respect to the variable x, taking the derivative of 3x squared plus 5y squared with respect to x, remember we treat y as a constant, the derivative of 3x squared is just 6x, the derivative of 5y squared, because there's no x variable involved, that means 5y squared is a constant, the derivative of a constant is always 0, so the derivative will be 0, we'll say 6x plus 0 or just 6x. Then what we'll do is evaluate this partial derivative at the point 1, 2. So we'll say the partial derivative of f with respect to x at the point 1, 2 is going to be equal to 6 times x, or because x is 1 here, 6 times 1, which is 6. So then we can say that this here is the value of a that we're going to be plugging in here for a. Now we need to find b, and remember b is just the slope of the tangent plane in the y direction, which is the partial derivative of the function f with respect to y evaluated at the point we've been given. So finding the partial derivative of the function with respect to y, the derivative of 3x squared will be 0 because we treat x as a constant. The derivative of 5y squared will be 10y. And then when we evaluate the partial derivative with respect to y at the point 1, 2, we're going to get 10 times 2, which is going to be 20. And so 20 is the value that we're going to be plugging in for b. So now that we have all of the values we need, we just go ahead and plug into our linear approximation formula. This is also the formula for the equation of the tangent plane. Remember, we're going to leave z, x, and y here. So what we're going to get is z minus z sub 1, which we already said was 23, is going to be equal to a, which we know is 6, times quantity x minus x sub 1, or x minus 1, the value we were given in our coordinate point, plus b, we know b is 20, so plus 20 times y minus y sub 1, y minus y sub 1 we already know is 2. That's the y value from the coordinate point we were given. So we could now leave the equation of the tangent plane in this form, or we can go ahead and distribute the 6 and distribute the 20 to simplify further by collecting all of our constants. So if we wanted to simplify further, what we would get is z minus 23 is going to be equal to, distributing the 6, we get 6x minus 6. Distributing the 20, we get 20y minus 40. And now if we collect all of our variables and collect all of our constants, because we want to order our variables alphabetically, x, then y, then z, and because 6x is positive over here on the right side, we want to go ahead and keep all of our variables over here on the right side. So we'll say 6x plus 20y, and then we're going to subtract z from both sides to get the z over here on the right. So we'll say minus z. So that's going to take care of the 6x, the 20y, and the z. We want to collect all of our constants over here on the left-hand side. So if we look at the right, we have a negative 6 and a negative 40, so we have a negative 46 over here on the right-hand side. If we add 46 to both sides, that'll get rid of the 46 over here. So we'll add 46 to both sides. Negative 23 plus 46 is a positive 23, so we'll end up with a positive 23 over here on the left. And then we can say that the equation of the tangent plane is 23 is equal to 6x plus 20y minus z, and that's how you use linear approximation to find the equation of the tangent plane at a particular point.